Good afternoon, students. Today we are going to see the next unit, that is the 10th unit, oscillations. So you know that what is an oscillation? So oscillating means it's moving. Yes, 2/4 it execute. That means the movement has to be to and fro motions. That is an oscillations. You know that. So have you seen the Tanjavur dancing doll? So that is shown in the figure. You see this doll, right? So in Tamil it is called as an Tanjavur Talayati Bommai. So it's a world famous Indian cultural doll. What does this doll do when disturbed? It will dance in such that the head and the body move continuously in to and fro motion. So until the movement gradually stops. So similarly, when we walk on the road, our hands and the legs will move front and back, right? So if you are walking on the road, your legs and the hands will be obviously to move to and fro motions. So and again similarly, when a mother swings a cradle to make her child sleep, the cradle is made to move in to and fro motion. All these motions are different from the motion that we discussed so far. So when the movement, generally they are known as oscillatory motions or the vibratory motions. So a similar motion occurs even at the atomic levels also. When the temperature is raised, the atom in a solid vibrate about their mean position or the equilibrium position. So the study of the vibrational motion is very important in engineering applications such as designing the structure of building, mechanical equipments, etc. So you know what is an, so in the swing, if you are sitting in the swing, you are going to and fro motion. You go and again come back to the original position. So that is the oscillatory motion. Okay, and next we pass on to the periodic and non-periodic. So you know that what is in the classes also you are having a regular periods, right? What is that a different period means? It will have a regular timing in between. If 40 minutes means after the 40 minutes gap you will get the another period. So it's a periodic one, means it will have the regular interval of time. So non-periodic, obviously it is a non-regular periodic time, right? So what is a periodic or a non-periodic equation means? Motion in physics can be classified as a repetitive, that is a periodic, and the non-periodic motion. Periodic means any motion which repeats itself in a fixed time of interval, that is a regular time of interval. It will be repeating again. There are class periods also, okay? First period, after the second and the third, like that it will be repeated again and again with the fixed timing, that is known as a periodic motion. Or otherwise the hands in the pendulum clock. Did you see the pendulum clock? It will be going and again coming back with the regular interval of time. And swing of the cradle and revolution of the earth around the sun, waxing and waning of the moon, etc. These are all the examples of the periodic. And non-periodic motion is nothing but that does not repeat itself after a regular interval of time. That means it's known as a non-periodic one. For example, the occurrence of the earthquake. So it's a non-periodic one. And also the eruption of volcano. These are the non-periodic. So what is periodic means? It will be coming back, that is a repetition will be taken place with a regular interval of time. The repetition does not taken place in the regular interval of time, means that is non-periodic equation. Understood what is a periodic and non-periodic equation, students? So what is the next? We are going to pass on to the example. That means some things will be given to you and then you have to find out that what is in periodic and the non-periodic motions. So what are the classification has to be given means motion of the Halley's comet is given and motion of the clouds and movement revolving around the earth. So the first one, that is a motion of the Halley's comet, that is a periodic one because it will have the regular interval of time. And the second one is what? Movement of the cloud. So what is the movement of the cloud? We don't know that. That means we know that it's a non-regular interval of. That means it's a irregular interval of time. So that it's a non-periodic one. And the last one, that is a movement, the move revolving around the earth. That is a periodic one. And the next example is which of the following functions of time represents a periodic and non-periodic? That is first one. the sine omega plus cos omega t, it's a periodic one, and in natural log of omega t, it's a non-periodic one. Okay, and next we pass on to the what is an oscillatory motion. When an object or a particle moves back and forth repeatedly for some duration of time, its motion is said to be oscillatory. You know that, okay? For the duration, for a particular time, it will take, and it will be moves back and forth, and it will be the repetitions will be there, like a swing. So the repetitions will be there for some duration of time. So that is the oscillatory one. The examples are our heartbeat. It will have a regular interval of time, and that will be again. It will be. We are know that the movement will be with the regular interval of time, unlike sweeping motion of the wings of the insects, and then the grandfather's clock, that is a pendulum clock, also having the same thing. Note all that oscillatory motions are periodic, whereas all the periodic motion need not to be a oscillation in nature. Okay, but all the oscillatory motions are periodic. Not all the periodic motions are oscillatory, because oscillatory means what? It will be moving back again, to and fro motion. If there is a to and fro motion, then it will be a oscillatory one. Okay, but normally periodic means it will have a regular interval of time. If there is no to and fro motion also, it's a periodic one. But if there is a to and fro motion and also the regular interval of time, that is oscillatory motion. Okay, then the pictures has to be given. See here, a dog is swinging, so this is a oscillatory or vibratory one, and the movement of the kangaroo is given. And next we pass on to the simple harmonic motion. What is in simple harmonic motion? So the equilibrium positions are to be given. See here how it will be. See this picture very clearly. They are given as a equilibrium position. Which is equilibrium? At the center only it will have the equilibrium position. Okay, so what is that simple harmonic motion? It's a special type of oscillatory motion, but all the oscillatory motion need not to be a simple harmonic one. So what is that simple harmonic motion? Means a special type of oscillatory motion in which the acceleration or the force on the particle is directly proportional towards the displacement from the fixed point, and is always directed towards that fixed point. So in one dimensional cases, let us x be the displacement of the particle, and the ax be the acceleration of the particle. So what is that acceleration? Acceleration is nothing but the acceleration of the particle, then ax, and then x is the displacement. So what is given as acceleration is proportional to the displacement, that is ax is proportional to x, that is ax is equal to minus bx, b of x, that is b is a constant which measures the acceleration per unit displacement, and dimensionally it is given as t minus 2, and by multiplying the mass of the particle on both the sides, so from the Newton's second law the force is given as, what is the Newton's second law by the force? So that is that they are multiplied with the masses on both sides, so you will get that fx is equal to minus kx. K is a force constant, and which is defined as a force per unit length. So the negative sign indicates the displacement and the force both are opposite in direction. So that means when the displacement of the particle is taken towards the right of the equilibrium position, that is x takes positive value, and the force or the acceleration will point towards the equilibrium, that is towards the left. Similarly, when the displacement of the particle is taken towards the left of the equilibrium position, means the x takes the negative value. So the force will point towards the equilibrium, that is towards the right, means it's known as the restoring force, because it always directs a particle executing simple harmonic motion to restore its original position. So that is the restoring force. When restoring force is central, so the attractive whose at center of attraction is equilibrium position. So in order to represent in 2 or 3 dimensions, we can write using the vector notations, that is F vector is equal to minus k r vector. So r is the displacement of the particle from the chosen origin. So note that the force and the displacement have the really linear relationship. This means that the exponent of one force F and the exponent of the displacement R are unity. That means the sketch between cos magnitude of the force and the effect, that is the magnitude of the displacement, is in the straight line passing through second and the fourth quadrant. Okay, so that is given as in the diagram. Okay, that is given in the diagram. See here, by measuring the slope, that is 1 by k, one can find the numerical value of the force constant. So k is equal to 1 by slope, slope is equal to x by f, that is 1 by k. So these are the simple harmonic motion. Okay, understood what is in simple harmonic motion? Okay.